Okay, so next we need to compute the square root of dt for the anneal step at 1200 degrees. And remember, this one is going for a much longer time. Okay, and so that's equal to the square root of the diffusion came out to 2.8 times 10 to the minus 13. And that the units for that are centimeters squared per second. Okay, same as the book. And then times the time, and the time is going to be 6 hours, but we need to cancel seconds down here, so I have to multiply by the conversion factor from hours to seconds, and so that's 3600 seconds. There's 3600 seconds in 1 hour. Okay, and getting the calculator. I'm going to do square root, and then I put on some parentheses, and then 2.8 times 10 to the minus 13 times 6 times 36. 3600. Close the parentheses and enter, and that gives us a value of 7.777, I guess all around too. So that's 7.777 times 10 to the minus 5, and that is in centimeters. Now if I make this one smaller, got to make this one bigger, so that's 10 to the minus 4, and so the centimeters goes to 10 to the minus 4 centimeters is equal to a micron, so this is 0.78 microns, just like in your book. Okay, and then the next part is to figure out finally we get to the first part of the problem, QT. QT equals 2 over the square root of pi times the source concentration at the surface of the wafer of the dopant, and also times the diffusion value, diffusion constant times time. And this will be the one we calculated for 1100. Okay, and so I just take 2 divided by the square root of pi times c sub s, which is 2 times 10 to the 21 per cubic centimeter. They said that that was the value from figure 2.4 for the saturated, the solid solubility of arsenic and silicon, and so that's where that value came from, how much arsenic can be dissolved in silicon, and then times this value up here. I'm going to go back to the centimeter value of that, which was, if I convert that to centimeters, it's 0.030976 times 10 to the minus 4 centimeters. Okay, and so I can get out the calculator and see what that comes out to. move this down a bit so you can see. Okay, so 2 divided by the square root of pi times 2 e to the 21 times 0.03097 e to the minus 4, and enter that, and I get 6.99 times 10 to the, let's see how many of these are there. So there's 3, 6, 9, 12, 15. So 6.99 times 10 to the 15th power. And the units on this is going to be, see, this is centimeters, this is per centimeters cubed. So our units are per square centimeter, written like that. 6.99 times 10 to the 15th, and that would be atoms per square centimeter at the surface. Now, one thing I forgot to say is that this formula is only valid in the case of the delta approximation, what they're calling the delta approximation, which requires that the initial depth of the dopant is much less than the final depth of the dopant. And that's true because this one came out to be the depth of the dopant was 0.03097 microns, and that is indeed much less than 0.78 microns. So this one is only 0.03, this one is 0.78. So this one is much less than that one. So that holds, and so therefore it was appropriate to use the delta approximation for part A.